All right, so applications and benefits of geothermal. I will start off this section by just saying that geothermal can fit into about any home or facility. You do not have to design a home or facility around a geothermal system. We adapt to you. So we figure out, we have products that would basically decouple themselves from the package or the air handling section from the heat pump section, and we can figure out the best way to apply to a home or facility through a design perspective. But our benefits, typically what we advertise is that we're 400 to 500% efficient. I'm going to throw out that 600 as well with new products that are now available, and they produce that much of an efficiency. Then what we see for savings is 30 to 70%. I think that that's being a little conservative. I saw personally on my little farmhouse that we're in, now we saw 80% savings. So then also if you have an all-electric geothermal system, you have no greenhouse gases. In other words, we're not burning any fossil fuels unless you were to have that hybrid geothermal system we just spoke on. It also provides outstanding humidity control and comfort in a home, because we're going to run at a very low speed, and the consumer can set their thermostat at a level that's comfortable for them and walk away. So it's kind of like the magic oven, set it and forget it. Improved air quality. Everything's indoors and has an excellent filtration system opportunity associated with it. And then also hot water assist as well, which almost comes standard with every system that we have available. We can also say that we also have hot water heating systems, dedicated systems that would do 100% too. I can get to the next slide here. All right, so another application that we do a lot of, especially as we get further north, is we do radiant systems. So they work very similar to a boiler setup. However, our belief is all about that design of the system up front. So we believe in tight spacing and low design temperatures. If you can design a system at low design temperatures, the system's going to run less, run more efficiently, and the lifetime of that system is going to be extended much longer. So we say that PEX tubing is cheap. Put that in the floor and do that well, and the consumer will have a very long lifetime for their equipment and a very low bill. So we do this in combination with forced air systems, and we do a lot of systems where we do it in the basement and or the garage in a typical house, and then in many homes we'll do it on the main level as well. We don't see it a lot on anything more than the main level because the heat rises so much if it's insulated well that the second story or beyond doesn't run a whole lot. So it's not needed a whole lot. Another system we actually call radiant hydronic. We need it to be more of a statement that we can handle cooling and chilling and heating. So we can use that for pool heating as well, and we'll get into a case study that we did down the road here in the presentation on pool heating. You can do snow melt, patio heating, etc. But I will be honest and say that the only feature benefit to snow melt is it's the most efficient, or I'm sorry, it's the most environmentally friendly way to heat the space. Unfortunately, whenever we're doing snow melt, it just takes so much ground loop and so much geothermal equipment that it takes away a majority of our benefits. But it leaves us with one, and that is the most environmental way to do so. And it eliminates the need for ductwork on heating side systems to actually increase our air quality. So if we're moving around less dust and things in the air, the better we are. So we'll see in the majority of the winter that our ducted systems are running very little and our radiant systems are running a lot. So we'll do radiant systems in shops as well in the concrete slabs. And I will say that a vapor barrier is not enough. You need to have at least 2 inches of insulation underneath the radiant system itself, and then also you need it out the sides of the slab as well. So an ICF construction is great for that, and you can, in your concrete forms, put in your 2 inches of insulation up on the sides as well, because that's actually where you lose the most energy on a radiant system. So this is actually, this image here on hot water is a pool that one of our customers put in, and they have their geothermal system heating this pool, and it could cool it if they wanted to reverse it as well. I don't know how much they do. But the equipment itself is located in the house, and you can't see it anywhere in their environment here affecting the atmosphere of their pool. So we're actually on hot water heating. We cut the costs of hot water heating by 25 to 40% and lowers the power demand of the home. And then also, as I said, we can do pretty extravagant pool systems as well. So something that Brett asked me to mention is actually indoor air quality and air filtration. And that's typically not something, a conversation we have a whole lot about ourselves, but because you can apply, we make it so that you can apply any type of indoor air quality onto the system that you would like. It can be as little or as much as you want. And we also integrate ERVs and HRVs into our systems as well if they are needed. We try to encourage our designers, if you will, to not include an ERV or an HRV unless you absolutely need it, because when you do so, that does increase our heating load a little bit more, which makes us add more equipment, or a bigger size, rather, to the application. And so we just ask for a very good design to make sure it's needed.